Hello my dear students, welcome to my lecture series on Mathematics 1. The subject code is BSc 103. In Mathematics 1 there are 5 modules. We will start with first infinite series. So let's start with infinite series. So before going to that infinite series course, I would like to introduce myself. I am BANERJEE'S from Kolkata. So before going to start with infinite series, we need to know about some basic idea about the course sequence. So what do you mean by sequence of number? So a sequence of number is a list of number written like this: A1, A2, A3, An in a second bracket form. Basically, we can define mathematically a sequence as a function from the set of all natural numbers to the real number set for a real sequence. So how we can define? Like, for every integer from I is equal to 1 to infinity, there will be a real number that may be equal, may not be equal, whatever, but it should contain a definite order. Okay, definite order means this we can write the general form of this AI, then that is called a sequence of real numbers. Like, suppose if we take an example of this form 1 by 2i. So this is a sequence. Why? If we put I is equal to 1, we will be having 1 by 2, then for I is equal to 2, we will be having 1 by 4, then for I is equal to 3, 1 by 8, like this it will go. So what will be the nth term? Nth term will be 1 by 2 to the power n, sorry, 1 by 2 to the power n. So n is equal to 1 by 2 to the power n. So we can write a sequence like this. Okay. Now if we take the next example like this, suppose a sequence is going like this: 1 by 2, 2 by 3, 3 by 4, 4 by 5, like this it is going to infinity. Now if I ask you what will be the nth term for this sequence? So n, what are the nth term? Now see the numerator goes as 1, 2, 3, 4, like this. So I can write at the nth step, if suppose this is A1, then this is A2, this is A3, this is A4, then n will be what? Numerator will be n and denominator will be 1 increased to n, that is n plus 1. So n I can write as n by n plus 1. So first we have to understand how to write a sequence, the general term of a sequence. Okay. Now we can when we are talking about sequence of numbers, now this sequence may converge, may not be converge. Convergence means what? If a sequence of numbers A1, A2, A3 up to An, then infinity, if this tends to some fixed value, unique fixed value, then we say that will be the limit of the sequence. So suppose L be a real number. If the limit of sequence n is L, then we can write limit n tends to infinity, n is equal to L. That means as n goes to infinity, the value will be L. Okay. So mathematical definition is given such as like this: if epsilon is greater than 0, for every epsilon greater than 0, for every arbitrary epsilon greater than 0, this is very important, every epsilon greater than 0, that means you can consider as small as epsilon is possible, but that is greater than 0. For that, if there exists some number m which is also greater than 0, such that absolute value, absolute difference between L and n, that will be less than epsilon whenever n is greater than m. That means what? For there will be some number m, after that we will be having all these value, this n tends coincide with this L value. All these values of this A1, A2, A3 coinciding with this value L. Like if I draw this pictorial figure like this, where this y axis denoting the values of A1, A2, A3 like this, and this is the natural number set 1, 2, 3, 4, 5, 6 like this. So, suppose for 1 this is your L, okay, this number is L. Now, the sequence is A1 is here, A2 is here, A3 is here, A4 is here, A5 is here. Now, suppose M, there exists some M, so some value M may be 1000, lakh, 1 lakh, 2 lakhs, whatever. For fixed M, if we have after this M, whatever the value you choose, that is M plus 1, M plus 2, M plus 3, all the value of this A1, A2, A3 just coinciding with this L. Then we say that limit exists for this sequence and the limit will be L, and we must have this L value is unique. Now, if there does not exist this finite L, then we say the sequence is divergent sequence. Sometimes we may have that the sequential value oscillates between 2 or 3 values. Like if I consider, we will study, whenever we will give some example, at that time it will be clear more, that sometimes the value of L may vary in between 2 numbers, like -1 1 or 0 1, then that type of sequence are called oscillatory sequences. Okay. So, some properties of this sequence you can consider. The properties are, suppose 2 sequences are there, AN and BN, 2 sequence AN and BN, where AN converges to L and BN converges to some K, some fixed number K, both are finite. Then limit n tends to infinity AN plus minus BN, that will converge to L plus minus K. Okay. Similarly, if the sequence, all the terms of the sequence, that is suppose AN, A1, A2, A3, A4 like this, and if each term is multiplied by some number C, then the series the limit of also multiplied by C. So, there is another property. Again, limit n tends to infinity AN into BN, that will be also L into K, but we have to have that limit n tends to infinity AN series and BN series both are convergent series. Okay. Similarly, dividing property is there, limit n tends to infinity AN by BN is equal to L by K, where BN should not be 0 and K should not be 0. So, there are some few properties of sequence. Now, come to the classification of sequences. We can, by the properties of sequences, we can classify the sequence. First of all, consider AN as a sequence. Okay. So, if we look at the sequence values, suppose AN a sequence, sometimes you can see the values are in increasing order, sometimes you can see the values are decreasing order, and sometimes maybe sometime it is increasing, some portion it is decreasing, some portion it is increasing, or it is oscillating like this. So, a sequence is called monotonic, monotonically increasing sequence if all the terms always are in increasing order. That means A1 is less than equal to A2, less than equal to A3, less than equal to A4 like this. That is the all the time we must have AN plus 1 is greater equal to AN. Then we say the sequence is monotonically increasing sequence, and if the reverse, that if A1 is greater equal to A2, greater equal to A3 like this is decreasing way, then we say it is monotonically decreasing sequence. And constant sequence also you can consider as a monotonic sequence, because equality sign is there. So, a sequence is said to be monotonic sequence if either it is monotonically increasing or it is monotonically decreasing. When the equality sign is not there, then we say the sequence is strictly monotonically increasing and strictly monotonically decreasing if the equality sign is not there. Now, we are having some few examples. Look at the first sequence 1, 1 by 2, 1 by 3, 1 by 4, like this it is going. So, what will the nth term? N is equal to 1 by n obviously. Now, tell me, is this sequence is monotonic sequence or not? Is this sequence is monotonic sequence? See, as 1, 1 by 2, 1 by 3, 1 by 4. So, the values are always in decreasing order. So, we can say this sequence is strictly monotonically decreasing. In the second sequence 3, 5, 7, 9, 11 like this, the nth term is 2n plus 1. So, this sequence also monotonically increasing, this sequence is strictly monotonically increasing. Now, if I consider the constant sequence 5, 5, 5, 5, this is a, you can say monotonic sequence, not increasing, not decreasing, simply monotonic sequence. Now, 4, is this sequence monotonic increasing or decreasing? Minus 1, then 1, then minus 1, then 1. So, neither it is increasing not decreasing. So, you cannot say this is monotonic sequence. Now, I am giving this one as a task, that check whether this sequence is monotonically increasing sequence or decreasing sequence. What you do for this, you just write down first its a nth term is n by n plus 1 and a n plus 1 term, that will be what? N plus 1 by n plus 2, and subtract that 2, and if n minus a n plus 1, check whether it coming greater than 0 or less than 0. I am giving as a home task to you. If it is greater than 0, suppose n minus a n plus 1 coming greater than 0. So, we can say what? A n is greater than a n plus 1. So, the sequence will be decreasing sequence. If it is less than, then it is increasing sequence. So, I am giving as a home task. Next, bounded sequence. So, bounded by the means you can see that a sequence n is called bounded above if there exists a real number m such that n is less than equal to m for all n. So, that means if there is some upper bound m, that always n will be less than equal to m, then this m is called the upper bound of the sequence. Okay. And similarly, if there exists another number suppose capital N such that n is less than equal to n, then we say the small capital N as the lower bound of the sequence. Now, if for a sequence n both lower and upper bound exist, then only we say the sequence is a bounded sequence. Okay. So, when I say it is bounded, if both bounded above and bounded below, then we say sequence is bounded sequence. If it is only bounded below, then we cannot say, and bounded not bounded above, then we cannot say it is bounded sequence. Okay. So, for to be a bounded sequence, it must be bounded below and bounded above. Again we come to the same examples. Now, let us try one by one. First sequence. So, what are the range of this sequence? See, 1, then 1 by 2 is monotonically decreasing and decreases to what are the limit? N tends to infinity n. What will be the limiting value? If we take limit n tends to infinity n, that will be tending to 0. So, the minimum value will be, the values of this sequence lies in between 0 and 1. So, lower bound we can consider as 0 and upper bound we can consider as 1. You can consider also other values. Suppose we consider lower bound is minus 3 and upper bound is 8. No issues, but there should exist at least one set of values n and m such that in between that n and m all these values of the series lies. Then only we can say this bounded sequence. So, first one is bounded. Now, come to the second one. What will be the minimum value? 3, 5, 7, 9, like this it is going. Minimum value we can see 3 and it is increasing order. So, n tends to infinity, this value will be what? increases and goes to infinity. So, it is the sequence is bounded below, but not bounded above. So, this is sequence is unbounded sequence. Okay. Now, 5 5 5 this sequence is constant sequence. So, you can choose any two values, suppose 4 and 6, in between this we have the all values. So, you can say this sequence also bounded sequence. Similarly, this one also is bounded in between -1 and 1. This one, what about for this one? So, the values are 1 by 2, 2 by 3, 3 by 4. If you take limit n tends to infinity, what will be the maximum value? Take limit n tends to infinity, you will get the value is 1. So, the maximum value will be 1 and minimum value will be 1 by 2. So, I can write there exist two values, this must exist two values, in between that two values all the values of this sequence lies. So, this is also a bounded sequence. Okay. Now, another thing, bounded and monotonic sequence. So, we are studying about sequences and convergence. Okay. When I say the sequence is convergent sequence, if there exists a finite unique limit, just we have discussed, a sequence is called bounded sequence if there a sequence is called convergent sequence if there exists a finite unique limit for that. Okay. So, now there is a theorem that if a sequence is bounded and monotonic, then it must converge. Okay. So, see again the previous examples, this sequence is monotonic sequence, also bounded. So, this sequence must converge, and you can check limit is 0, so convergent. Okay. This is not monotonic increasing or decreasing, not a monotonic sequence, but bounded. This sequence, see the fourth one, this sequence is monotonically, not monotonically increasing or decreasing, but it is bounded, but we cannot say this will be convergent sequence. So, a n is equal to -1 to the power n is not convergent sequence. Okay. Next, I am leaving other to think to you that whether they are convergent or not. Okay. So, think about number 2, number 3, number 5, okay, whether these are convergent or not. Now, we come to our main part, that is the infinite series, which we will suppose to talk about. So, for this infinite series, what is an infinite series? First, the definition. Suppose a n is a sequence of numbers, a n is a sequence of numbers, the terms are a1, a2, a3 up to a n. Now, if we sum up all these terms, that a1 plus a2 plus a3 plus a4 up to n plus to this, then this is called an infinite series. Okay. So, the terms are going to up to infinity. So, suppose we have just see the a n sequence is n by n plus 1 as a sequence. So, now we are summing up all these values, then this sequence is this is called an infinite series. Now, in infinite series, the question arises here whether as n tends to infinity, so whether this sum have some finite value or not. So, the question here arises that this series is an infinite series. So, whether the some finite sum exists or not for this series, that is the main question here. If there exists some finite sum, then we say the series is convergent. So, what we do, suppose S1 is equal to A1, S2 is equal to A1 plus A2, S3 is equal to A1 plus A2 plus A3, Sn is equal to A1 plus A2 plus A3 plus n. This is, so we have a sequence of numbers, we are constructing one sequence, that is called the sequence of sum of the sequence of the sum of the sequence of sum. partial sum, sequence of partial sum, this A1, then A1 plus A2. If this sequence of partial sums S1, S2, S3, if this sequence converts to some fixed value S, then we call the infinite series has a solution, the infinite series has a finite sum. So, Sn is equal to A1 plus A2 plus An. So, if this Sn series, this series is converts to some value, suppose S, then we say this series is convergent and the sum value will be S. If S is an infinity, if is S coming infinity, then we say it will be divergent. Now, another thing sometimes occurs, another part, that sometimes we can have this S value coming vary in between two values, suppose S1, S2. If it varies in between S1 and S2, then we call this series is oscillatory series, oscillates between two values. Okay. Now, there are some properties of the infinite series, just like infinite sequences. So, if An is equal to A and Bn is equal to B are two series which converts to A and B, and C is any real number, then these properties must hold. Okay. Just look at the property. If C is multiplied with the series, then the sum will be multiplied also by that C. Again, summation or subtraction of two series will be addition of or subtraction of the converging values. Okay. So, up to this I am stopping here my first lecture. We will continue this in next lecture. So, just to summarize what we have studied, first of all, the what is sequence, what are the criteria for convergency of a sequence, what is monotonic sequence, what is monotonic increasing and decreasing sequence, when we call a sequence is bounded, and also the definition of infinite series. That much we have studied today. So, you just go through this first. Next we will come to the next lecture with some specific series, and we will continue with the test of the series. So, let us stop here today. Have a nice day. Thank you.